All right, welcome to your first flip classroom. We're doing a lesson on laws of exponents. If you notice, we have this grid here, and it has all of your properties, your rules, and your examples. You do need to copy this into your notes. If you'd like to, you can pause the video so you have an opportunity to copy this down. But I'm going to go ahead and begin explaining or going through all of the examples, and then we'll have some examples that you can practice on your own, or you can just follow along as we do them. So the first property we're looking at is the product property. With laws of exponents, we're going to be looking for like bases. Whenever you have the same base and you're multiplying like bases, you add their exponents. And so that's where we get the m plus n after we multiply x to the m times x to the n. Over here to the right, we have a couple examples, and you see here that we have x squared times x to the third. They have like bases, so we add their exponents, x to the fifth. 3x squared times 2x. Whenever there's not an exponent, we assume that the exponent is 1, so the exponent on that x is 1. So 3 and 2 are not exponents, they are coefficients. They do not follow the laws of exponents. So we treat them like regular numbers. 3 times 2. It is 6. That's where we get the 6 over here. X squared times x. Like I said, when you multiply like bases, you add their exponents. That's where we get the x to the third. And again, when there's not an exponent, you assume that it's a 1. Our next, sorry about that. So looking here at the quotient property, whenever you divide like bases, you subtract their exponents. And I do see a mistake here in the notes. It should be x to the m, so we'll just go ahead and fix that real quick. X to the m divided by x to the n, they are like bases, so we subtract their exponents, x to the m minus n. If you look over here at the examples, you have x to the 6 divided by x squared, and so subtract the exponents, and we get x to the 6 minus 2, or 6 minus 2 gives us x to the 4th. If you look at the next example, you have 4x to the 6th over 6x to the 8th. The 4 and the 6, again, are not exponents. They do not follow the laws of exponents. You treat them like regular numbers. They are coefficients. So 4 over 6 reduces to 2 over 3. Now if you notice here, I have x squared in the bottom. Well, x squared is actually, the x squared being in the bottom is because of this rule here, the negative exponent rule. And the way that I teach this is that the side that has the most gets to keep the exponent. So if we wrote out x to the 6th, that's x times x times x times x times x times x over x times 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 x. And hopefully you're not having to do that every time. Hopefully you understand this idea. And so if we look here, when we do division, similar numbers cancel each other out. They make 1s, which we don't have to write. So these x's cancel each other. All right, there's 6 on the top. There were 2 on the bottom. That's why we get x squared in the bottom. And that actually saves us from having to apply the negative exponent property. All right, moving on. You have the power property. The power property, whenever you take a base to a power, you multiply the exponents. And so if we look here at this first example, we have x squared to the third. So you're going to take 2 times 3 and get 6. Now again, and this is something I always have to point out, if we look here, the 2, again, the 2 is not an exponent. So the 2 does not follow the laws of exponents where you would do the multiplication. So 2 to the third power, 2 to the third power is 8. Okay? And then x squared to the third power, take a base to a power, you multiply the exponents. 2 times 3 is 6. All right, probably the easiest property to apply is the zero power property, which just states that anything raised to the 0 power equals 1. It doesn't matter how complex. If it's raised to the 0 power, it's going to equal 1. And then our last property is the negative exponent property, which I've already referenced. But if you have a negative exponent, you can bring it down to become positive. So anything can be written as over 1, And so if we had x to the negative 1 over 1, you can just bring that negative exponent down and it becomes a positive. And so I don't have to write 1 when it's positive, only when it's negative. And so if you notice down here, there's a blank. Okay, it would be a 1 there, but we don't have to write it. If you look here at our examples, x to the negative 2 becomes 1 over x squared because the x to the negative 2 is over 1. And then vice versa, if you have a negative exponent in your denominator, you can bring it to the top as a positive exponent. All right, let's move on to look at some examples. And again, you can pause this video at any time and reference your notes. If you need to pause this video and go back and reference the explanations of the previous section, you're more than welcome to do that. And I would suggest that you pause the video at times so that you can try practicing this on your own for class tomorrow. All right. So in this first example, which property are we going to apply? Good. The product property. Okay, so we see we have like bases being multiplied together, and so we add their exponents, and we're going to get x to the 7th. Okay. Again, in this next example, we're going to use the product property. All right. 4 and 2 are not exponents. They do not follow laws of exponents. 4 times 2 is 8, and x squared and x to the 5th, we add them together, and we get x to the 7th. If you found yourself writing 6x to the 7th, you would be incorrect. All right, let's move on to our third example. We have negative 2z to the 3rd power. Remember, coefficients, numbers in front of our bases, are not held to the laws of exponents. So when we have negative 2 to the 3rd power, we actually have to take negative 2 to the 3rd power. Negative 2 to the 3rd power is a negative 8. And then z would have an exponent of 1. And so 1 times 3 is 3, so we just get z to the 3rd power. And again, if you need to pause this at any time, you may, and that was the power property. All right, let's move on to the next example. Back to the product property. In the product property, again, coefficients. Make sure you check them out. They're your big numbers compared to your bases, which are your exponents, which are smaller numbers. 5 times 2 is 10. And then x squared times x is x to the 3rd. And y cubed times y to the 4th is y to the 7th. Okay, remember, product property, you add. All right. Next, we have the quotient property. And so 125, 100 divided by 25 is 4. You can put the 1 below if you want, just to represent that there was a 25 there. And now we're going to do subtraction. And what I would suggest to you is just, you always want to take the bigger number minus the smaller number with your exponents. And then that result will either go in the top or the bottom, depending on which one had the most to begin with. So here, I'm going to do 2 minus 1, which is 1. There was 2 on top, so the x's stay on top. But with your y's, there's 3 on top, 5 on the bottom. 5 minus 3 is 2. So we're going to get y to the 5th, y squared in the bottom. And then we have z squared and z to the 4th. Again, do 4 minus 2, and the result is 2, because there were 4 z's in the bottom, which was more. Z stays in the bottom, and so we get a z squared. Okay? All right, and then our last example here is 4x squared y cubed to the 0. And like we said before, it's the easiest property to apply. It's our 0 exponent property. And so anything to the 0 power is 1. All right, thank you guys. Again, if you need to rewatch this video, you may go back through the examples. Make sure you have all these notes completed for tomorrow. They will be checked to see if you have all the examples written down. And then this is what you will be using to do your classwork.